Hi everyone, we will solve GATE 2011 question number 15. Lift on an aircraft climbing vertically up is often A equal to its weight, often B 0, often C equal to drag, often D equal to thrust. So this problem related to climbing. So for climb you can refer to this NPTEL lecture. So first we will see what is the steady climb. In steady climb, aircraft move to up above the horizontal plane. So in this figure, thrust is acting on the and thrust is acting with angle alpha t with the flight path. Flight path is with the velocity v, and this flight path is making angle theta with the horizontal. Lift is perpendicular to the flight path and drag is along the flight path in the opposite direction. Weight is working perpendicular downward. So this angle will also be theta, and so now we will resolve forces perpendicular to this flight path and along the flight path. So along the flight path, this thrust will be T cos alpha T, drag will be minus T, and component of weight will be minus W sin theta. Equal to this force will be equal to, let's say this acceleration is dV by dt, so it will equal to mass into acceleration. Along the perpendicular direction, net force is T, component of this thrust will be T sin alpha T, and component of base is minus W cos theta, and this will be equal to, let's say there is slightly curvature of path, has a slightly curvature with radius RC, so its force will be mv square upon RC. These are the equation of motion for the steady climb. So now you see in the problem it is given that it is climbing vertical up. So one aircraft is climbing vertical up. So this thrust will be only in this direction. We assume that alpha t is very small. If alpha t is very small, then this radius of curvature is infinity. Then this equation will come T minus D minus W sin theta, and there is no acceleration, so it will equal to 0. Second equation will be L minus W cos theta equal to 0. So now in the problem it is given that if theta equal to 90 degree, so you put theta equal to 90 degree in this equation will come T minus D minus W equal to 0 and L equal to 0. So by this we get that lift is equal to 0. So that is no lift. Even if we draw the free body diagram, we see that thrust will act upward along the velocity direction. Thrust will be opposite to this and lift will be perpendicular to this. So if we balance the force, then we will get, and weight W will act downward. So if we balance the force, we will get T minus D minus W equal to 0 and L equal to 0. So lift is 0. So our answer will be B 0. Thank you.